reference point as well as the position of object. We will find where what is the reference point, where is the reference point, what is the position of object. We are starting from this. Yes, lecture name of lecture is motion. Name of lecture is motion. Motion. We will start. We will start from reference point. It is coming in concept of motion. Let's start. When you hear motion word, then you should be clear that something is moving or something is in motion. Something is moving. It will be better to understand motion. Okay, motion, it means object is moving, something is moving. Object can be solid, object can be liquid, object can be gas. For example, particles. Particles are gas. Water is liquid. Liquid. Water, you see motion of water, you can see. Motion of object also you can see. Motion of solid object. So meaning of this is what? Something is moving. This is meaning of motion. Now reference point. It is also object. We will consider a object as a reference. Why? Why will we consider any object as a reference? Because of need. According to need, we will consider any object as a reference point. According to need. One point is you are clear that reference will be object. Reference will be object. We will use object as a reference so that we can find position of other object. We want to know location of object, then we will have to consider any object as a reference from that we can identify, we can find, so that we can find the position of our location. That's why we will take other object as a reference so that we can find location of our location of our address. Yeah, sorry. Clear. So why is a reference object used? Because reason is because it is used to find location of other object. Clear? Now position of object. How to identify? How to find a position of object? Just see who is observer, what is a reference point, which object is a reference point. Just identify. Okay. If you are saying that this is observer, this is a reference object, then just you would say okay, don't worry. This is a tower. Let's say this is a tower. Clear? This is a tower. Let's say this is a tower. Clear? And this is road. And here is what? A college. You can say a school. A school. Clear? This is a tower. Now this is also object. This is also object. Clear? A person wants to know location of a school. A person wants to know location of this school, and he went to other person. This person went to other person to know, to ask that where is the location, where is this location, what is the location of this school. So of course it happens with many person where we don't know location of a strange place, then we ask to someone, we ask to someone so that we can go direct where we want to go. That's why we ask. Yes, it happens or not? Yes. So that's why a person went to other person to ask a location of a school, and B person said that location of this school I know, and I can say, I would say that just go straight, and you will reach to what tower. You will see tower. Just go straight, and then this side you will see what tower, and just just for 20 kilometer, not 20, just 2 kilometer, 2 kilometer distance would be 2 kilometer from tower that you will see. So just go, uh, cover, cover 2 kilometer distance from tower, then you will get location. You will find, you will have what location of this school. So here B person took this tower as a reference point. Yes, B person said that just you will see after covering few distance, you will see what a tower. Now to cover, just cover how much a distance? 2 kilometer distance from tower. Then you will be where? At this location. So here B person took this as a reference point. Clear? To tell a location of this school. That is how we consider any object as a reference point to tell position of other object. Clear? Clear. Now here, what is a relative? A relative and absolute. Absolute. What is a relative and absolute? Tell me. Relative, which means we are not confirmed. We are not confirmed. Here we will take what? Observer. We will take reference point. Okay. In the case of relative, we have to take what? Observer. Who is observer? Who is a reference point? In the case of absolute, it would say that that mass will be same. Mass will be same. For example, distance. This distance will be same for me, for for other person, for other observer. This distance from this school and to this tower, this distance will be same. It will not change at all. Okay, something is not changing. Something is fixed. He will consider that as a absolute. But in the case of relative, what will happen? Here we will take observer, because now here, as you know, this is in state, this is. I will tell you about it, but before that, rest and motion. Rest and motion. About rest and motion, I would like to tell you about it, because it is taught. It is taught in starting of this lecture. That's all. Yes, rest, which means something is in rest. For example, of course, a school will be in a rest. This tower will be in a rest. They cannot run. They cannot run. They cannot move. Can we move a school? Can we move a tower? No, at all. Here, this is in rest. That's why we would say this is at rest. So something is at rest, and that object is not taking time. For example, this is object, as we know, this is school is object, but it is in rest and it will not take time. Time will be passing. Time will be passing, but this school will not be moving. That's why it is in rest. Now, what about motion? Something is moving. Something is moving. Object will move. Object will be in motion. Object will be in motion. Okay, from this we will understand a relative. We will understand a relative. Something will be in motion. And if there is a motion, of course, motion will take time. It is a universal truth. You can say yes. Any kind of motion, any type of motion will take time. Will take time. Okay, always remember. But any object which is in rest will not take time. Clear? This was the difference between rest and motion. Okay. Now, from here, let's understand a relative. Let's understand relative. Here, I am taking a observer. I am taking a observer. A observer. Okay, this person. This person. This person. Okay. What else? Yes, a vehicle. A vehicle. Otherwise, you can say a truck. Okay, a truck. A truck. Clear? A truck. In this truck, there are some boys. There are some boys, and two boys are here. One boy is riding. One boy is driving this truck, and one boy is sitting beside of the boy who is driving. Now, apart from this boy, there are some more boys behind this. Where here there are some boys who are sitting in this box. Okay. Now, this is one observer. This is one observer. This is not moving. This vehicle is not moving at all. This also is not moving at all. From this example, we are understanding what is the meaning of a relative. We have understood meaning of absolute. Meaning of absolute, something is a fixed. We cannot change at all that thing. Okay. For example, distance of this between this is a kilometer. It is a fixed. We cannot change. But here, from relative, you will get confused. That's why we take a word observer. That's why we take a reference point. Now here, this is observer who is standing on road and he is not moving. This vehicle is also standing on road, but this vehicle is also not moving at all. Both are in a rest. Can you say? Can you say? Time is passing. Time is passing, but he is still standing. He is not moving. This vehicle is also not moving, and time is passing. Now you would say both are in a rest. Now this vehicle starts running. Driver of the vehicle starts driving. Starts driving. Now this person is still standing. He is still standing on the road. Now this vehicle is moving. Question arises, what? let's just say six boys. Okay, six boys are here and two boys are here. Now here, question is: are six boys in motion or not? Are these six boys in motion or not? You would say vehicle is moving. Vehicle is moving, but boys are not running. Boys is not moving this side, that side. Vehicle is moving. You would say I cannot say completely. I cannot say completely because vehicle is moving, and in vehicle those boys are in that vehicle. You would say 50% boys, but where boys are moving? Where are boys moving? 50%. So here you don't have complete answer. That boys, six boys are in motion or in rest. You don't have complete answer. You cannot answer this completely. So to answer this question, you have to take observer. You have to take reference point. You have to take observer. Who is observer? Who is observer? That's why we would say, and here it is said that motion will be relative. Motion will be relative. Motion will not be fixed. Okay, motion will be relative. A rest thing will be absolute. Okay, will be absolute. Things that are in rest will be absolute, but things that are in motion will be considered as relative. Here, this vehicle was moving. This was standing on the road. Question was: are these boys in motion or not? Now, now, and question is not saying who is observer, who is not observer. You have to tell. You would say the boys is also moving, boys is not also moving. Boys is not moving, but vehicle is moving. But where is the answer? Complete answer. Where is the complete answer? Now here Kishan is saying that observer is this person. Now you are taking observer. It means you are saying motion is a relative because you have to take what observer. That's why this motion is what a relative. Clear? Because we are not able to answer completely. That's why we are taking observer. Now, according to this person, all these six boys are in rest. I think so. Yes, yes. According to this person, all these six persons are in rest. But hold on. You can say according to this person, all these are in rest. No, this both persons are in vehicle. According to this person, this six boys will be in rest. But according to me, it seems that six persons will be in motion. Even I am getting confused. Why I am saying that according to this six boys will be in motion? Because according to these two boys, this six boys will be in a rest. Six boys are in rest and they are not moving at all. Okay. According to this person, this vehicle is moving. According to this 6%, this vehicle is also moving. So it is absolute. But here, what is written? According to this two person, this is 6 persons are erased. But according to this person, this is 6 persons in motion. This is 6 persons in motion. That's why this motion is relative. Clear? That's why. Now let's move on the next topic. Now next question. Not question. Next will be concept. Distance, displacement, distance and displacement. First, then second, then third. What is the distance? Look, with an example, I will tell you meaning of a distance and displacement. This is your home. Okay, and this is your college. You travels like that. Like that. It is your state in your area. To go to college. It is a state. You travel like that. You go like that always. Because it is a street, that's all. It is a road in your area to reach here. Now you know that the distance from here to till here is how much? You would say 3 kilometer. You would say 3 kilometer. This is so total. Total is how much? Total distance is how much? 3 kilometer. From here to till here, like that. So here you will take total length, total distance of length, total distance of length. You will not avoid any distance. Okay. From here to till here, total distance is 3 kilometer. To define distance, you will take total length. Okay. To define displacement, you will take shortest distance. It is also distance, but you will take shortest distance from initial and final. This is initial and this is final. Straight you can say, and shortest. This is shortest. This was long. This is the shortest. And now from here to till here, it is a 1 kilometer. It is how much? 1 kilometer. So you would say shortest distance. To define the displacement, we take shortest distance. Here. Now what else? Quantity. Which quantity is a distance? Distance is which quantity? A displacement is which quantity? So always remember, distance is a scalar. I will tell you why. a scalar, a scalar quantity, a scalar quantity. It is a vector quantity. Now let me tell you why is the distance a scalar quantity, y is the displacement vector quantity. Remember, meaning of a scalar is what? Any quantity has any quantity. No. If this has what? Distance has, or you can say a scalar quantity. It has what? Definition. I am telling you definition of a scalar quantity. Distance no, a scalar quantity. It is a quantity. It has only what? Only magnitude. This has only magnitude. You can say magnitude. Understand? Only magnitude. A scalar quantity will have only magnitude. Now question is, what is the meaning of magnitude? This is also strange word. Yes, it can be strange word for you. But meaning of magnitude is what? Meaning of magnitude is value. Value. What is the value of something? For example, here 3 kilometer. 3 kilometer is a value. Okay. We take number. Here we are measuring something. That's why we took a kilometer. That's why I wrote a kilometer, because here we are measuring we are measuring length. That's why. Now here kilometer is a unit, and unit will be considered as value. Unit will be considered as value with a number. Okay. As you know, unit tells you what is being measured. Unit tells you what is being measured. For example, liter will tell you that volume is being measured. Here same kilometer is telling you length is being measured. Length of something is being measured. So that's how you are able to understand that something is being measured, and you are able to identify how, because of unit. Unit is given. That's all. So here 3 kilometer together we will consider as a value. Now it is a value. Can you say it is a magnitude? Value is magnitude. Magnitude is value. Clear? Only magnitude. Now what about vector quantity? Vector quantity will have also magnitude. But what will be the difference between a scalar quantity and vector quantity? If it has a magnitude, it has also magnitude. What will be the? One more word I would like to add on here. Then there will be a difference between magnitude as well as a direction. As well as direction. Now you can see difference between them. It has magnitude, but it has both magnitude and direction. Yes. Magnitude vector can have will have. You can say will have. Vector will have magnitude as well as direction. Any magnitude don't have. Any magnitude does not have. I'm not telling you that it will happen. Here I am telling you the scalar quantity will have magnitude, vector quantity will have magnitude and both are direction. Direction which means which sides. This is side, all this is sides. These are directions. You are saying this is side. So you are telling this direction of this is this side. Like magnitude, you say that this number, that number, that value. Clear? Now here 3 kilometer, only this 3 kilometer is a water distance, and 3 kilometer is only magnitude, because it is a value, only value. Now when I say 3 kilometer it is in state, it is what, it is in south, it is in south, otherwise you can say it is in, it starts from, it is in south and west, you can say south and west, it is in south and west, it means between south and west. Okay, so here between south and west, it is giving you direction. So 3 kilometer, 3 kilometer college would be in this direction. Distance between this two is how much, 3 kilometer and college, and when you will measure this 3 kilometer, then you will find college in this direction, in this direction. College will be in southwest direction. So now 3 kilometers southwest direction is what, this place. Now it will be positive. It will be always, you can, it will be always positive. Clear? Always positive. Only positive. Distance will have positive. Always remember. Always remember, distance does not have negative or zero. Now you can say it can have a zero, but it will not be negative. Remember, it will not be negative. Clear? Now here it will be always positive, it will not be negative. Here it can be positive, it can be positive, or negative, or zero, because here we have direction. Here displacement will have direction, that's why direction can be this side. So here this side, let's say this side would be negative, this side would be positive, and reference point here between, so this would be at a zero. So here we are taking negative, positive, zero, because this is this side, so all these are direction, that's all. Remember, this displacement will have positive, negative. Here you can see displacement is positive. Now one point more you have to keep remember in your mind, that displacement here displacement will not be greater. Always remember, it will not be greater, than distance. Always remember. Always displacement will not be greater than distance. Clear? For example, this distance from here to till here total was how much? 3 kilometer. No, displacement is 1 kilometer. So from this statement you can say displacement can be less than distance. You can say distance was 3 kilometer and displacement is less, but displacement will not be greater than distance. You can say distance is 3 kilometer, but displacement is not greater. Okay, you can also say it is an universal truth. It is universal truth. It is a fact. Now one more point. Yeah, displacement will be equal to, can be equal to distance. Yeah, sometimes you will realize that distance and displacement both are equal. It will happen sometimes. Did you understand something? Shall we move? Shall we move? Here you can see what is the meaning of this sentence. It is telling you what if distance your road is, you have a road, you can travel from here to till here direct. This is the road, okay, this is a straight road. Now question is asking what is the distance from here to till here, from home to college. You would say 1 kilometer is a distance, is a distance. Now question is also asking what will be displacement of this. You would say 1 kilometer, 1 kilometer displacement, because it is a straight, it is the shortest. That's why it is not a curve. It is not a curve. And both, you can see both are equal. That's why I wrote here that displacement can be equal to distance. Okay, it will happen sometimes when you have a straight line. Then I am going to erase it. I am going to erase it. Can you see this all text that I wrote in front of you? Yes, you are able. All this text are visible to you. This was concept. Now next. Next. Speed. Next is a speed. I just remember a speed will try to tell you here. You will understand difference between them. Both are looking same, but what will be difference? What will be the difference? Here, meaning of a speed is what? It is telling you a speed of this bike, a speed of this vehicle, a speed of this person, a speed of this animal is this much, is this much, is this much. What are you understanding? You are understanding here, you can understand here, this speed will tell you which one is slow, which one is fast. There are two animals, you can say both are lions, okay, both are tigers. There are two animals and those two animals are moving very fast, okay, very fast, but it will not be more sufficient to take this. Two trucks, you can say two vehicles. This is a road A, B, clear. And here till here is how much? It is 20 kilometer. This is also 20 kilometer. Clear. Now a vehicle both starts both start what driving at the same time. This vehicle reached till here within a you would say 15 minutes, not 15, 25 minutes. 25 minutes. And this vehicle reached here 35 minutes, within 35 minutes. You can see which one vehicle covered the same distance within a less time, and that vehicle will be considered as that vehicle was very fast. So here this vehicle took less time and this vehicle took more time only to cover same distance. Distance was the same, but here this time is less. That's why we can say this vehicle, the speed of this vehicle was fast as compared to this vehicle. And that's how you identify a speed of a vehicle, a speed of something. Clear? Are you clear that a speed will tell you fast or slow? Will tell you fast or slow of object. Clear? You can see, you can see with how much speed you are driving. If you are riding a bike, then you can see a speed where in your speedometer device. Yes, you heard is right. A speedometer is a device which is found in vehicles. If you are riding a bike, then you can see a speedometer, and a speedometer will tell you a speed of your bike. A speed of your bike. Okay, who will tell you? A speedometer. But what about a speedometer? Okay, a speedometer. What about odometer? What's the difference between? A speedometer will tell you in meter per second, but odometer will tell you in kilometer per hour. In kilometer per hour. It will happen. A speedometer is telling you in 1 second how much meters, how much distance in 1 second, how much distance in meter you are covering. Are you covering? In 1 second, how much distance of meter you are covering? Who will tell you? A speedometer. And from that meter per second, you can consider a speed of your vehicle. Now, odometer will tell you within a 1 hour how much distance. Within a 1 hour, how much? Within a 1 hour, you will consider. Okay, I am not talking about it. Odometer telling you that you covered 5 kilometer within a within a 2 hour. Okay, 2 hour. What is happening? Otherwise, you can say 1 hour. Okay, 1 hour. And it's telling you you are covering 5 kilometer distance. You are covering how much? 5 kilometer distance in 1 hour only. Okay, so you covered how much distance? 5 kilometer. But it is telling you your vehicle is moving with this much speed. With this much speed. You will understand that in 1 second I am covering this much meters. This much meters. If in 1 second you are covering 1 meter, 2 meter, so you will understand that my vehicle is moving very slow. In 1 second is covering, you are covering what more meters, then it means your your bike, you can say in less time you are covering more meters. It means your vehicle is moving very high. Okay, in some seconds you are covering middle normal or lesser normal, you can say, then your vehicle is moving slow. And in second you are covering lesser more less meters, then you can say your vehicle is moving very slow. This was meaning. And here meaning of this is what you are covering 5 kilometer, you are covering distance of 5 kilometer within a 1 hour. This is meaning of this. Clear? We were understanding this. How to calculate a speed? Just find the distance and total time taken. Total time taken. Of course, as you know, something will move, that motion will take time. That's why time taken is came here. Time taken came here. Here we are finding what a speed. A speed. We are finding a speed. That's why we divide total distance by time. Total distance by time. To find out distance, you can multiply a speed from a speed by time to find distance. So distance, for distance, what will happen? You will give a speed multiple total time taken. Time taken. You are multiplying, means you will get collection. You will get collection. So a speed was this much. You can say 5 meter per second and multiple uh, time was 10 seconds. So meaning of this is what you covered 50. Okay, clear. Now what about the velocity? What's the difference between them? Both are same, but here remember this is also a speed, but it will take the direction. Velocity will take direction, but a speed will not say that I am taking direction. Okay, velocity will say that I will take direction. If I am not taking direction, if velocity is not taking direction, then we will not consider uh, that. So any magnitude is taking. If we are taking direction with a magnitude, then we will consider that the speed as a velocity. If we are not taking direction, then we will consider that as a speed. Clear? This is the difference between only direction. Here we are not taking direction, here we are taking direction. That's it. Formula is the same. Here you can see distance does not have direction, displacement has a direction. Clear? This was the difference between them. Both are speed, both are motion, but I am telling you only direction is a Direction is correct. No. What about average speed? What about average speed? Average speed. Meaning of this would be u plus v upon 2. U plus v upon 2. And average velocity would be u plus v upon 2. But you can say both are same. Both are same. Both are same, but here we will take a direction. I am telling you again and again. So here u will be considered as initial speed, and we will consider as a final speed. If here you will see what if a speed is increasing or decreasing, then we calculate average speed. We will use this formula when when a speed is decreasing or increasing, then we use average speed. In our daily life, it happens what we increase the speed of our vehicle, we decrease the speed of our vehicle according to it. Sometimes somebody comes in front of our vehicle, then we decrease the speed of our vehicle. Yes, it happens or not? Yes, that's why we calculate average speed. Okay, that's why here we took initial speed and final speed. From initial speed, final speed, you will find, okay, avoided. Now here in this, same here, but here same direction. Here direction. Remember, u will be considered as initial speed, and here u will be considered as initial velocity and final velocity. From this concept, you will understand acceleration. Okay. From this acceleration, what is the meaning of acceleration? Meaning of this is very simple. If a speed of a vehicle is increasing or decreasing, both are happening. Okay, both are happening. If not, a speed is a constant, then we would say that acceleration is a uniform acceleration. Okay, uniform acceleration. We add uniform word with acceleration because here we are telling that acceleration is a constant. Speed is not changing, speed is not increasing or not decreasing. Okay, that's why we add uniform with acceleration to define this. Now, simple acceleration. We can say now a speed can increase, can decrease. If a speed is increasing, then we would say acceleration. If a speed is decreasing, we would say deceleration. Okay, clear? Now you are clear. What will be formula to calculate acceleration? I think velocity upon time taken. Velocity upon time taken, isn't it? V minus u upon t. Yes. V minus upon t. Here I am subtracting. Here I was adding. Also here I was adding what both the initial and final speed. But here I am subtracting from final velocity. I am subtracting initial velocity from final velocity, and then I am dividing both by time. This is formula of acceleration. We are subtracting this from this because we want to know what was change. Acceleration will tell you change of velocity. rate of a change of a velocity. That's why we are subtracting. That's why we are subtracting initial velocity from final velocity. And what was the time taken? Okay, what was the time taken between them when a speed was increasing? A speed was increasing then. Okay, clear? So here from this formula you will find change, a speed of a change. Okay, as vehicle was moving with constant, then immediately suddenly that vehicle increased the speed. Then from that until the end, till then where velocity came into zero, otherwise you can say. So from this formula you will be able to find change of a speed, change of velocity. What was the change? Now here unity, here you will get meter per second as well, and here you will get a meter per second. Here also meter per second, RMS value, because here you are finding a speed, not kilometer. Here you are finding for acceleration. So for acceleration you will get meter per second a square. What is the meaning of this? Meaning of this is what? 2 meter you are covering 2 meter distance. How much distance? 2 meter distance. You are covering 2 meter distance within 1 second. Within a 1 second. You are covering how much? 2 meter distance within a 1 second. And now you will be covering same. You will be covering same 2 meter, again 2 meter. For example, 2 meter. Then again 2 meter. How much? 4 meter. Then again 6 meter, like that. So in each second you are covering how much? You were covering how much? 2 meter distance in each 1 second. Here in 1 second 2 meter, again 2 meter, again 2 meter. That is the meaning of this meter per second a square. Here a square is telling you that per every second, again second is coming, then you are same distance coming again and again 2 meter per second. Clear? Now uniform motion and non-uniform motion. What do you think about it? About non-uniform motion? What do you think about uniform motion and non-uniform motion? What do you think about it? Meaning of both are very simple. Just understand carefully. Uniform, meaning of uniform word is what? It is telling you something is equal. Something is equal. For example, when we used to go in a school, then we used to wear what? Uniform dress. So dresses were equal for all students. Color, you can say, color of dress were equal for all students. Same here. Same here. Meaning of uniform is the same. Meaning of uniform is the same. It is telling you something is the same. Something is the same. Uniform. It means motion is the same. Now here it is telling you distance will be same. For example, from here to till here 5 km. Okay, clear? otherwise 6 kilometer. From here 6 again, from here 6 again. I am telling you meaning of this uniform motion. We will have what two things, one distance and second time. That's all. Now to cover this 6 kilometer, time taken, time is how much? You would say 21 minute. 21 minute. Clear? Only to cover 6 kilometer. I am not talking about this wall. Only this wall. This 6 kilometer. To cover this time is how much? 21. Now again, question is saying that from here again time is the same. Time is the same. Time is the same. You are covering 6 kilometer. You are covering 6 kilometer in 20 per minute. Per minute. Per minute. You can say per minute, per 21 minute you are covering same 6. Distance are same, minutes are same. Here you can see this is same, this is same, distance is same. After 6 years you are same covering, you are same distance covering within a same distance, same time. Again it is happening. And now this motion, you have what motion? Now this motion, what is the name of this motion? We will consider name of this motion as a uniform motion, because interval time is the same with the same distance. Interval time is a distance. Interval time is the same. Interval time is what? 21. This is interval time, and distance is the same. Clear? So meaning of this, what did you understand? You understood that you are covering 6 kilometers per minute. Per minute, not per 21 minutes. You are covering how much a distance? 6 kilometers. Again, within a 21 minute you are covering same distance. Again, within a 21 minute you are covering same distance. But it will happen with your life. It will happen when you will be driving. Then this will be very less chance that this will happen with you. This motion will be this motion you will be doing. This will happen. It will be less chance. Here you can observe in your life. You see non-uniform motion in your life. When you are driving, then you can observe non-uniform motion. Odometer will tell you. Odometer will tell you. For example, you can see after 1 hour, you will see that I covered this much distance. Then again after 1 hour, you see what initially you saw that you covered how much? You saw where? On odometer. Okay, odometer. You saw that you covered 3 kilometer within a 1 hour. Okay, within a 1 hour. You saw on odometer. Now I am telling you again after 1 hour you see that how much distance now you did cover. You would see odometer is telling you how much? 2 kilometer. Odometer telling you how much? 5 kilometer and within a 2 hours. You can see what is happening. What is happening? Odometer tells like that. Now this is a complete. This is complete from initial. Okay, we have to find from this how much a distance you cover. You would say 2 kilometer within a 1 hour. you can see here. Initially you covered 3 kilometer 1 hour, and now you can see 2 kilometer. So distance are not same. Yes, hour is the same. Hour is the same, but distance are not the same. It happens because you are riding bike. You are in a real life. Okay, it will happen. That's why I am telling you non-uniform motion you will observe many times in your life. This uniform motion you will observe sometimes in your life. Clear? So you understood what if distance and interval time is equal, then that motion is a uniform motion. That motion is a constant. Now here interval time is the same, but the distance are not same. Sometimes the distance will be the same, but interval time would not be same. So motion, that motion we will consider as a non-uniform motion. I hope you understood something from this. Let's take a next concept. Now, what about a uniform circular motion? Circular motion and non-uniform circular motion. What do you think about it? It is clearly telling you not a uniform. Something is moving in circle. Something is moving in circle. You can see. For example, I am drawing a circle shape like that. Okay. A object here is moving in this circle. Now, a speed of this is constant. Meaning of this is what? It is saying that it is covering a speed of this is what? 3 meter per second. 3 meter per second. A speed of this. And this is constant. With this speed, this object is moving in circle. And this is happening again and again after completing one circle. So if a speed is a constant, then you can say that motion which is in circle is a uniform circular motion. Okay, we understood what is uniform motion. If something is moving in circle and distance is the same, interval time is the same, then we can consider that motion as a uniform circular motion. But what if a speed is changing sometimes, a speed is decreasing sometimes, then we would say the motion of this moving object in a circle is what is considered as non-uniform motion. Clear? Because a speed can increase sometimes, a speed can decrease sometimes. That's why we can consider like that motion which is increasing, decreasing as a, we can consider it as a non-uniform circular motion. Okay. Now, time graph. Here I am drawing a horizontal, this is vertical, not horizontal. This is a horizontal. This is 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is 1, this is 6. This is 6. Now here we are considering this a timeline as a time or what else. So what? Okay. So here 1, 2 hour, 3 hour, 4 hour, 5, 6. We are considering these numbers in hours. In hours. Okay. In hours. We are considering this timeline as a distance. 10 kilometer, 15, 20, 25 kilometer, 30, 35. These are distance. Distance. Clear? Distance. These are hours, these are distance. Now always remember, if you have a direct a straight line, horizontal line, not a vertical line, horizontal line. If you have horizontal line in a graph, then you have to understand that some object vehicle is in a rest. Vehicle is not moving. This graph is given to you. This line is a horizontal line. Okay. Now it is telling you covered 25 kilometer. Your vehicle covered 25 kilometer distance, but after covering 25 kilometer distance, you are in a rest. You are at rest. Now after completing 25 kilometer distance, you are not moving at all. This is the meaning of this line. Clear? So here you can say your vehicle is not moving. This was meaning of this straight line, which was horizontal. Now what else? If line is curved like that, also remember this is what this was horizontal. Will it give you uniform motion? No, because it is not moving. Vehicle is not moving here. Here, this curved line will give you what? Will give you this this curved line is giving you non-uniform motion, and that is a fact. Curved line will give you non-uniform motion. You can see what is happening. This is not curved like that. Okay, like that. This curved line. This curve. Look at this. Here it is telling you vehicle is here. You covered 10 kilometer. I am talking about this. You covered 10 kilometer within a 1 hour. Within a 1 hour. So you can say you covered how much? 10 kilometer within a 1 hour. Clear. And now this vehicle is reaching here. Here, okay? Here. What is happening? You can see same. Now 50 kilometer. 50 kilometer. But from here to till here, okay? 5 kilometer. 5 kilometer. And then how much your time? 1 hour. And now vehicle came here. Vehicle came here. This is not in front of a total. And this is not in front of two. Now vehicle is here. Vehicle is here. What is happening? Vehicle covered 18, you can say 18 kilometer. 18 kilometer. So from here to till here, how much? 3 kilometer. 3 kilometer. Within a how much? You would say 1 hour. Otherwise, you can say 40 minutes. 40 minutes. You can say time is changing. Distance are also changing. That's why we can consider both are changing. Sometimes time will be same but distance will be changing. Sometimes distance will be same but time will be changing. So something is changing, we will consider motion of that vehicle is what is considered as a non-uniform motion. Clear? So that's why I was telling you curved line will give you a non-uniform motion. Non-uniform motion. Clear? Like that. Now, what if we have this straight line like that, like that? This is not horizontal line. This is also not vertical line. This is something else. But okay, this is given to you. This is given to you. Can you see this? This okay. Now this straight line will give you a uniform motion, not non-uniform motion. Uniform motion. Here you can see. This can give here. It is here. Okay. Now within a 1 hour, 10 kilometer per hour. Okay, per hour. And now it is here. It is here. Within here again 5 kilometer. 5 15 you can say 15 kilometer within a 2 hour. 2 hour again here 20 kilometer within a 3 hour. What is that? Now you see what is the interval distance and interval time. Here you can see interval distance is 5 kilometer and interval time is 1 hour. Interval time is 1 hour. You can see. So interval time is the same. Here 5 kilometer, here 5 kilometer, and here 5 kilometer. That's why we say interval distance is the same. Here 1 hour, here 1 hour. Here. That's why we say straight line can give uniform motion. Can give uniform motion. This is also known as slope. This is also known as slope. Why? Here, this is one and this is one. We will consider this as a S1 and S2. And here there is a T1 and T2. T2. This is slope. This is slope. Here, this is known as a slope. We would say delta S. Change, we will realize what we will realize change. What was the change from here? This change we will realize. Okay, this is what we are finding. This is what we are finding. So here you can write delta T delta y upon delta x. This is y and this is x. This is y and this is x. So we will subtract this from this from this. We took y, we took x, y because this and this. Here change, we are finding change. What is the change? This change we are finding. This was like that, but it came here like that. So what was this change? That is what we are finding. So we will subtract S2 minus S1. Now T1 minus T2. So S2 is how much? 20 minus 50. And T2 3 minus 2. So it came 5 upon 1. So you can see changes how much. And you can delta can be represented as dy upon dx. You got how much? 5. 5. This 5 number is a change. This 5 number is a change. You cancel 5 kilometer, otherwise this 5 is. That is how you find slope. Okay, slope. That is how.